Hello and welcome to this IGCSE talking paper. Now looking at Edexcel Physics and in particular looking at section B7, mains electricity. Okay, let's look now at the question, shall we? So it says here a soldering iron, so I lost my pointer then. A soldering iron is a tool used in joining electrical components in a circuit. It has an electric heater. Okay, fair enough. Now soldering iron A operates when connected to the main supply. Look what it says here, 230 volts and 30 watts. Okay, soldering iron A is labelled 230 volts and 30 watts. Now first of all, what does the 30 watts tell you about energy transfer in the soldering iron? Okay, think through it carefully. 2. This soldering iron has an earth connection, so an earth wire connected to it. Explain, so the explanation here, there's your command word, how an earth connection protects the user. So think, why do we have an earth wire? How does it protect us? Now, soldering iron B, okay, it's a second soldering iron here we got, be careful, second iron B, look at it, it's 24 volts, and this time it's 70 watts, so bear that in mind. Now, soldering iron B, as I said, level 24 volts and 70 watts, the student says, now I think that both soldering irons in a 3 amp fuse, so think carefully what fuse you might want to add to it, okay. Now what will you need to calculate to find out the 3 amp fuse is correct? So use information, use it, you've got it there, use it, from the soldering iron labels, plural, to evaluate this statement. We're looking for both soldering irons as A and B, so be careful. And lastly, there is a step down transformer in the power supply of iron B. Describe, this is a nice one here, describe the structure of a step down transformer. Okay, what do you know about it? You may draw a label diagram to help you answer. Okay, so pretty straightforward. So pause the video at this point, have a go, and we'll check out your answer in just a moment. So how do you get on? Well, the first one here, what does 30W tell you about the energy transfer? Well, W stands for watts, so it's a power rating. Power rating, or you could say it's the number of watts. Now what do watts tell you? They tell you the rate of energy transfer, so how many joules per second, or you could use that abbreviation there. So one mark here saying it's a power rating, or the watts. Second mark saying what it is, rate of energy transfer. Now this soldering iron has an earth connection. How does an earth connection protect its user? Very important these are. Now there may be a fault, maybe a loose wire, and that can cause a hazard. Okay. Now the current, because you've got an earth wire, the current goes to earth. It doesn't go to the user, i.e. me or you. It goes to earth out of preference. The fuse will get melted when it blows. This in turn breaks the circuit, and the current will follow a path of least resistance down to earth. So any 2 points there get you 2 marks. Okay, now then, do we need a 3 amp fuse? A 3 amp fuse, what do we need to know? Well, we know in both cases, we know the power rating, we know P, which is watts. We know that in both cases, don't we? And we also know V, the voltage. The equation we want is I equals P divided by V. Now we're doing it for both soldering irons, so be careful here. The first soldering iron, okay, it had a power rating of 30 watts and it was 230 volts, so 30 divided by 230 is 0.13 amps. Now that's much smaller than a 3 amp fuse. Let's see, the fuse is much larger, so poor choice. You're better off here choosing a 1 amp fuse. I thought there, 1 amp fuse. Okay. What about B? Well, B up here is 70 watts but only 24 volts. So divide 7 to 24, you get 2.92. Now, okay, it's below 3, but probably a little bit too close to 3, or a bit of a leeway. So in this case here, I'll probably use a 5 amp fuse. So not a good choice. Look at those calculations carefully, and make sure you understand them. Just out of interest, you know, the fuses commonly come in 1 amp, 5 amp, and 13 amp. Those are the common ones, and your cooker could be a 35 amp fuse. So make sure you know your fuse ratings. Now, there is a step-down transformer. The power supply, describe the structure. Now, transformers are primary and secondary cores. I'm going to draw this on. This is our talks here about soft iron core. There is your soft iron core. Okay, there. Transformer soft iron core. You've got a coil on this side here, so you've got a coil. Not very good drawing a coil, but forgive me for being rubbish about drawing coils. Okay, now this is your primary, so coming in is your primary coil, and coming out has your second. Now because it's stepping down, we've actually got fewer turns on this side, so secondary, okay, has fewer turns. So a transformer has primary, secondary coils. Primary and secondary has a soft iron core. The primary coil, the input, has more turns than the secondary because it's stepped down. Okay, got that? You get your 3 marks up here, get your 3 marks, and hopefully you got 10 marks over the whole question. So, big question for me is, how did you get on? So thanks for watching and listening, and I'll be back on the question very soon. So bye bye for now.